We should hit record here. Okay. All good? Make sense? Personal repo, team repo, meeting minutes, project proposal. Too long, didn't listen. Type music went away, so it's hard to pay attention now. Awesome. There's some extra credit here too, if you would like. So I love giving out extra credit in class. Gives you an extra chance to, do something cool if you want. Add a GitHub Pages website to your personal repo. So that's going to be in your future for the team page as well. But I'm not going to give you any guidance or directions on this as it's extra credit for now. But if you want extra credit, depending on how pretty and feature rich and complete it is, I'll throw some extra credit your way too if you go that route. Other than that, we have process models to cover today. Let's make sure this is full screen. I'm not blocking anything, and away we go. Now, process models. This is where we start talking about the nitty-gritty of software engineering. So this slide, if you looked at the PDF last night, we haven't really gone over these phases yet. In the book, they have. This book, which you are not in any way, shape, or form required to have. But the point is that we probably have talked about this in some fashion. So we've talked about writing code. We've talked about testing at a high level, right? And that we're going to have to create all these artifacts, and we have stakeholders and things of this nature. So we have some high-level idea of putting together a project. Now, the way we formally do that is with some kind of process. And I'm going to say the process, I'm going to put it in capital letters. Any project that is going to be of any sort of quality will have a formal process. And again, which process you pick is going to be dependent on multiple factors. More likely than not, unless if you are a senior member in your company or what have you, you don't have any choice of what the process is. It will be there waiting for you to learn. And I will put a caveat here. Every company will probably implement a process, some kind that we're going to talk about, and they'll probably have some differences. So they may put their own spin on things, right? And you're just getting kind of what the actual processes are here. But keep in mind, everybody's needs will be different. So if you have a company doing Agile, they might pick one of the Agile flavors and then tweak it for their needs. Just depends on, again, your company. So it is a process. At a high level, it is a series of steps, right? So it's a process. For software engineering, it's where your various engineering aspects, where your steps are placed and how often you can go back to them and whether you're even allowed to go back to them. What are the inputs to each step? What are the outputs to each step? All right, so it is a process. And I've got, oh, it's going wrong way. Darn. So for software engineering, what does this process mean? Every single step in our overall development process is going to be rigorously defined. Again, what are the inputs and outputs? Mention that, but what are the resources that are going to be used? What are the people involved with each step? What is the schedule with that? Which is kind of why I'm asking you to consider your project timeline, because you're going to have to figure out who's responsible for what, right, at which point of the process, and we'll formalize that later on. But kind of the point here is to get you thinking about software as an iterative developmental process, right? And not just inputs, outputs, who's responsible, but what are any constraints you may have, right? Maybe you don't have the technical knowledge at a particular point or the right person yet, or, you have some kind of a safety constraint where you can't necessarily, go too crazy with going out for extra modules because you have a rigorously defined set of test cases, and getting something else would violate them. All right, so process is going to be very, very important here. One of the keys as well is going to be consistency and structure. So from project to project, we're going to have... Is that on my mic? It is a day for children's moods today so far. Hopefully you're all doing good today. Anyway, Yeah, so doing projects in the same way over and over and over again is always going to be a good thing, right? It's rigorous, it's repeatable, and you can point to a consistent output of quality. Also, what is very important too is being able to reflect. Yeah, but it's okay. Awesome. Oh, yeah. Anyway, so if you have a project that goes horribly wrong, maybe it gets canceled for one reason or another, or you have a lot of problems at delivery, you can figure out what went wrong, do a lessons learned kind of activity or reflect on what happened and go back to the next project and take all of these experiences and bolster that process, right? Maybe your testing just sucked. I know you passed all your cases, but it wasn't rigorous enough. And then when you put it in the field, you have all sorts of problems. Well, you take that knowledge and then you maybe go out and start testing in the field a little bit more, right? Or you add in different cases where you're actually testing it in different situations that you never would have before. Or you do something more exploratory, right? So you try to figure out what went wrong and what you can do. This all is part of a nebulous process. So in software engineering, we're going to kind of talk about the process as one thing, right? And we have a whole bunch of different types of processes. They all more or less have the same ideas behind them. It's just where you slot them in, right? So there's going to be your proposal, which is kind of what you're getting at right now, a design phase where you figure things out, implementation, maintenance, and there's going to be different aspects to that. Point is that there is going to be a way to tailor this to your situation, just to read this last bullet for you there. How are we going to find any inconsistencies in your development process or maybe between requirements to delivered package and things of that nature? How are we going to actually create good software? Now, you can actually apply this to nearly any engineering project, honestly. We're software engineers, so we're going to consider this in terms of software, but you're going to have a life cycle of design. This could be the same for, a civil engineering project. We talked about that on day one. We're going to have a cycle involving requirements analysis and definition. So again, that's where we sit down, write out the pros requirements of what your software is doing. We have an architecture design where you're figuring out exactly where the high-level pieces are going to go, how they all interconnect. Think of this almost like a layer above almost class diagrams kind of thing. There are specific architectural models. I don't know that we'll get too deep into those, but we're going to be more in the more closer to code level of modeling. So we're going to go from kind of a high level to a more fine-grained level. We're going to actually start figuring out what the programs are going to look like. This is where you get into your things like class diagrams and things of that nature, which we'll probably start talking about next time, honestly. Writing the code or doing the implementation, right? We don't necessarily have to write code to create software anymore. You may have heard things called like a low-code environment where you draw class diagrams, you draw various models, and they automatically create code. Then you fill in the blanks. So coding is not always strictly coding, but you're going to be doing some kind of an implementation. Might be one of those what you see is what you get editors where you just drag and drop boxes or you do block programming or something of that nature. However you create your programs, you're going to have to do the implementation aspect. Then you're going to do testing. So testing should be done at multiple levels. All right, so unit testing, I really hope you all got in your Java class, where you test the input and output of your functions. You can more formally say that you're testing the preconditions and post conditions if you want, but basically what's going in, are you checking that? What's going out? Is it returning the correct values? Integration testing, that's where you have multiple modules. You might have a release over here, a release over here, so it's all like a software release, and then you're composing them into a system as a whole. So for instance, if it's a car, you've got a window module, a radio module. There's code for each of those controllers, but when you bring it together later on, I guess that's more of a system testing. Integration testing is a little more low level where you're bringing in all of your different changes and testing those. I'm getting ahead of myself, sorry. System level would be where you're bringing everything together at the end. Then you have your delivery. So clients get their hot little hands on our software and we see how that goes. There's going to be training, there'll be environmental testing, things of that nature, making sure that the client is happy with what they get. And then we'll have maintenance, right? So software development's never done. We always have to make sure that what we see in the field is still working correctly. Right, if you design an app or some kind of a software package, you're probably going to have some kind of a feedback mechanism for sending bug reports in, right? You might tell your client to click a Jira entry, or you might have a form that gets submitted whenever it crashes and get the stack trace of exactly what happened. However it's going to work for you in your situation, you're going to have to maintain your software. And the fun part about all of these entries here, so this is fairly standard, okay, but you might have different emphasis on various aspects here, right? So maybe we're not gonna do maintenance unless you pay us extra, or we're not gonna do a whole lot of deployment testing unless you buy that particular package from our company. It just depends on your situation. Enough high-level stuff. Let's talk about the actual models. And again, if you all have any questions at all as we go, feel free to stop and let me know. Don't be scaredy cat. Ha! Let's emote. Ha ha ha. But we have some different models here from older to newer. So basically, we're going from very, very inflexible to very, very flexible. And this is where I start talking about which model you pick for which situation. There are reasons to use the older models, there are reasons to use the newer models, and there's trade-offs for each of them. All right, just because something is brand new and buzzwordy, that's not necessarily a reason for you to go out and just pick it. Now, before I get too deep into this, I'm curious, has anybody that has worked in industry ever used a software model? I think I've asked this before, but I'm kind of curious. So if I recall last time, nobody actually had. I'd expect if you had an internship or something like that, you might have experience with one of these, but it's possible you haven't too. Everybody uses Agile. That's cool. Agile is the new one. So a lot of companies are very excited about Agile. And I will say this. When I worked in industry, so I was in automotive, we used the V model because we had very well-defined requirements because it was automotive. Freestyle model, there you go. So what we actually saw kind of in the 2000s, and I'm sure it's still happening, and this is gonna be a very esoteric kind of example, just something I want you all to be aware of because this will happen. You might go to work for a company, and let's say you're a development engineer, or maybe you're climbing the ranks, you're a project manager, what have you, and a new thing comes out. So industry is super excited about this new development model. It's supposed to make development super fast, your team's going to gel, life is going to be great. You get all these horrible industry buzzwords, and somebody's going to want to start using that right away. Let's jump to Agile++ or something. Okay. Well, the thing that's really hard is if you have existing projects using well-defined models, and then you want to jump to the new thing, and this is the old curmudgeon / cynic jaded engineer in me, it sucks for everybody if you go from one model to another mid-development. A successful team will start with a good process and typically stick with it. There is a huge headache and learning curve if you have to move from one model to another. Like I said at the beginning of your project, make sure you're happy with your choice. Otherwise, all of your traceability of all your artifacts, so everything you've created has to be redone for this new model. Everybody has to be trained. So this is my best bit of advice. Make sure you're happy with the model you're using. And again, these decisions are probably made well in advance. All right, first up, let's talk about Waterfall. This is one of the first software process models. The figure it out as you go model. Yeah, that's the fun. That's the term project model, right? All right, so here we go. So Waterfall, this is one of the first ones, and this is a very brittle model. So maybe let's put it that way. It is very hard to handle change. So these types of models, so there's Waterfall with blah, blah, blah extension, basically. But these types of models are great when there is not any ambiguity in your requirements, when everything is set in stone at the beginning of the project. Okay, so minimal to no changes. Basically, we have a whole bunch of steps, and the idea of waterfall is that you're like water flowing down this model, so you go from step to step to step to step. I've got a picture right here of what this actually looks like. But you have a nice high-level view of your development process where you start with, let me just go to this. You start with your basic proposal kind of way up here. Then you go into a requirements phase. Then you go into a system design phase. Then you start designing your programs. Then you do the coding. Then you do the testing and the testing and the testing. And then you go into your delivery and maintenance phase. So basically you start at one level and you just flow downwards towards delivery and maintenance. Does anybody see what the problem with this is? I said this is very brittle. Sounds good to me. Me too. But what's the problem with this model? Right, so you have to have good requirements, which any good project should have, right? You sit down, you write your requirements once, and you're done. That is exactly right. If your requirements change, you have to start over. And again, this is where I'm basically trying to get across to you all that you have to follow the process. Otherwise, auditing agencies get very mad at you, for one. You know, if you need that kind of a justification. Let's say I'm automotive engineer, because that's my wheelhouse. I'm working as a supplier, and I'm working for a project on one of the big three. So GM, Chrysler, Ford, what have you, foreign companies as well. We're building our module. It's the best thing in the world. We've gone through a process. We're doing our testing. Oh crap, we found a big problem. There is a glaring issue with one of our requirements that it's not considering, you know, rain spatter on a camera or fog or something. So there's a problem, and we detect this. We go back to the customer. Hey, we have to do our requirements again. Okay, well, how long is that going to take? Maybe another 6 to 8 months. And then we get to testing again. Or basically, you have the problem that you can't go back. So yes, it's hard to make changes. Now, if you're good with your requirements and they're never going to change, perfect. The same problem happens at any level, though. So you get to unit and integration testing, you find an issue with one of your classes or your functions, maybe it's returning the data in a wrong format, you still have to go back and redo a lot of things. So it gets very painful. Basically, the big issue here is that there's no possibility for iteration. All right, so here we have a lovely, completely connected graph between all of these common development phases. There is often going to be the case that you find something in testing that shows a significant flaw at some point, right? There are so many times where the engineer sits down to do all the mental work and that person's going to miss something. It's just human nature. We're not going to catch everything. So you need a way to be flexible, right? So flexibility is key here. So yeah, basically the issues here, there's no guidance for change. There is the idea that software is basically a manufacturing process, which, you know, in the 70s and 80s, when these models are being thought of, we think of software like an engineering manufacturing type of thing, right? It's iterative, but there's no going back once you make your product. Okay, so iteration's the key. We need that. There's also a long wait. So the customer never sees a prototype. The clients never see, you know, maybe where you're at. You just go from, okay, I am the customer, I have all these requirements, I'll see the final product in 2 years. You know, there's no iterative steps, there's no in between, no chance for feedback, right? Customers tend to like feedback. Now you can add a prototype step to Waterfall, and you can, again, modify these as you need for your company, as long as it's well documented what your process is, but there's still problems, right? So let's add a prototype in here. Let's get our customers' feedback. So prototyping is useful, right? You all make prototypes for all of your projects, you know, team projects, term projects, personal passion projects, right? I'm going to implement some cool feature. Here's my prototype. Is it done? No. But you get an idea of what your system will look like, right? So let me do my little, hey, I'm doing cool things too phase. So let's look at my horrible term project that I'm working on. I thought it would be cool to add in some basic NPC management. So is this a working prototype? No, but I've got a bunch of people wandering around my little town here, and I can talk to them. And that's a great example to show on stream that I put random names in. Forgot about that. But I see that these guys don't move around once I get close to them to make it easy to talk to them. Is it fully featured? No, but I have an idea of how things are. So prototyping is usually a good idea. Let's check our requirements. Greg Stinkface. Well, if you knew Greg, you would agree it was required. I have some much meaner names in there that I should probably take out before the next section. That's one of those I need to remove this before I show my class. Otherwise, they'll see how childish I actually am. So yeah, prototyping is useful here. So how does this look in terms of our model? So we have our same waterfall here, and we still see that we're flowing downwards, but we have little hooks to our prototyping stage. And we also have ways to go back in this process. So to you and to, somebody who's not an engineer, these arrows are just super easy to draw, right? But again, we know that there's a whole lot going on behind the scenes here of what these arrows mean. We have to get our customer feedback. We have to integrate that into our requirements. We have to go through our verification process again. So it is possible to add on X feature to a process. It just has to be documented and it has to be useful. Now, is Waterfall with prototyping useful? Yes, but we still have the problem that requirements have to be well-defined. Okay. All right, so that's Waterfall in a nutshell. There is a variation called the V model. So this is what I used when I was in industry. Units, so there's a couple points here which I should probably have removed. So Waterfall also can use integration testing, unit testing. So this is not specific to the V model. Testing is in any model now. But the difference here is that instead of a waterfall, we have a V. So I've got a few different pictures of what this looks like. But basically you have this kind of V shape here where, again, you start with requirements, you go through various design phases, you get to implementation, and then on the upswing is your various testings and maintenance. The key difference is that you have ways to go back at each step. So this figure's okay. I like this one a little bit better in that it's a little more, it's got a nice gradient, I guess. But it gives you a better high-level view of what you have. So the left side of the V is your project definition step. So go through these similar phases. You don't necessarily need to go back up one of the sides of the V, but you can get a pretty good idea. Then you get to your implementation, and then you do your testing and integration and release type of activities. This is where, the theory for this model is that if I find a problem here, I can go back pretty easily. If I find a problem here, I might have a requirements problem. If I find a problem here, there might be a very significant problem. We have to go back and start over. Right, so we have basically different views of what this V is. And it's actually a decent process. It still, however, requires you to have a good idea of what the requirements are. We still have a slightly brittle model in that if requirements change, we have to go back. The issue here, well, not issue, but I guess the benefit is that you don't necessarily have to go all the way back depending on what changed. Right? In Waterfall, it was important to go all the way back. Here, you have like a stepwise type of iterative feature. So it's only directly across. It depends on your V, I suppose. So depending on where you're at in the process, you have to follow basically the arrows. So which way can you go back? Again, processes are intended to be a rigorous set of steps. So if this is the model you're going with, that's what you have to go with, yeah. I mean, I suppose it's always possible, though, if you want to find a problem here, you can always start over. I guess there's a hidden arrow to go all the way back to the beginning, but usually that's something we want to try to avoid. So then if you look at it from maybe an artifact perspective, so we haven't necessarily talked about what the actual documents that we're going to have to create are, but we're going to have a couple of different levels of requirements, for instance. So business requirements are going to be a little bit more wordy, maybe a little bit more high level in terms of what features they want. System specifications, these are going to be your very granular, this is what module X is doing, what its inputs and outputs are, that kind of thing. Then you get into your design models and then your code. And then again, you're going up in your testing complexity. So unit testing to component testing to system testing, sorry, integration testing, then system testing, then is everybody happy with the model? So the left side, we're starting high level, we're getting granular till we get to the code, assembly if you're a rock star, I suppose. Then low level tests, still low level-ish, medium level, system level, customer level. All right, so we have these different aspects here. And then we have another view of it as well with different arrows. So depending on, again, your particular flavor of the model. Okay, so that is essentially the two older models. All right, so we had zip, way too far back. I thought I had a quicker view here. Waterfall and V. So these are the two oldish models. Whoa, yes, amazing. New arrows. Now we're getting into more prototypical models. And then we're going to get into the Agile, which is the newer aspects. So let me zip through these animations here. Okay, so prototyping is an interesting flavor of software design, where delivering prototypes is more of the focus than anything. Okay, so you start with requirements again. Now, the thing here is that we can have incomplete requirements. We can have perhaps informal requirements. Start thinking of this like your user stories, if you've heard of Agile, where the definition of your models is a little bit more fluffy, I suppose. I'll use that term. But basically you have an idea that I need some feature, here's kind of what I want it to do. All right, well, then we're going to get into this revision process of creating various prototypes. So I'm going to have a list of prototype requirements. These are what I think we're going to need, and I'm going to create some prototypes out of it. I can have multiple iterations of this process as well. So I have prototype version 0.0.1. Hey, customer, what do you think of this? It's good, but we need this, 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 and this. Okay, let's go back, update our requirements, go back again, new prototype. Are we happy, basically? So it's an iterative way of quickly releasing prototypes, and then you eventually get to your final version. So we have a flow here where we start with requirements and we try to refine them as we go, basically with the customer. All right, so we go through requirements, happy with prototype, go through our design, and again, design is a little more model-centric. So then we're going to say, okay, we have all these revisions. Let's feed that back into our prototype. Revise, 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 release, revise, release, revise. Then create your system as a whole. More revisions. Okay, let's go back. Do we have to update our design a little bit? We have to update our requirements a little bit. That means that our prototype has to change based on what we saw up here. And then after this whole kind of cyclical process, final testing, deliver the system. Essentially, you have a refined prototype. Key difference here, customers' views in mind, right? So here we have ideally a great way to handle nebulous or not great requirements. Okay, it's flexible. Limit number of revisions. Depends on who's interacting with your customer. Okay, we have infinite revisions for free. The really nice thing here, and there is a positive in that your customers get a lot of ownership over the product, right? They have a say in what it looks like as it goes. Key things here, you have to have a great line of communication and understanding with not only your customers, but your team. So you have to be able to relay these changes, be able to demo the prototypes, be able to go through all of that formal process of, okay, here's our weekly presentation to the customer or monthly or however it's structured. So it's nice, but the drawback is communication is going to be key. You also have the problem that the requirements changing on a, often, basically changing often. You're going to get into the state where, maybe it's too flexible, or maybe I'm going back and forth between features based on what the customer wants today. All right, so I should probably speed up here since we're almost out of time. Got 10 more minutes. But you can look at it in multiple ways. So we have basically incremental or iterative. It just kind of depends on your prototyping. So here in phase development, so this is a little bit different than prototyping. Phase development, similar, however, we're working on this version. Right now, this is what the customer has. So version N plus 1 is the development. So this is the next feature. Any of you that do any open source gaming, you know that release 0.25 is the current version. The unstable version is what we're all currently working on in the source code repository. And then you get kind of an idea of what version N is. You know what fixes or features you want in the next version. And again, it kind of floats back. It's very, very similar. So the idea is that you as a developer, you as a project manager, whatever you are, I'm going to put a release out. That's what the users will see. This will feed back into the next release, right? So you're already working on version 2 when people are using version 1. So kind of your almost early access model for gaming if you want to go down that route, which honestly has its pluses and minuses. As a consumer, it's hard to swallow, but as a developer, you get that feedback. I really hate the fact that I'm arguing in favor of that. I'm not necessarily doing that. But we have different views too, right? So each of these releases comprises a series of steps. So your planning, your modeling, your coding, deployment, all of these will be a part of a particular phase or increment or whatever it's going to be called. Key difference here. So incremental versus iterative, I use these without really telling you what they are. Incremental is where you start with some piece and you're getting towards a fully functioning prototype. So here is widget A, you tack on widget B, then widget C, then you have your full system. So that's incremental. I'm incrementing progress. Iterative is the other side, and there's nothing wrong with going one or the other if you're using this model. I'm going to start out with a full featured system. So I know everything that I want, but I'm going to refine each piece as I go. All right, so one is more incomplete, one is complete with holes, I guess is a better way to say it. So you have this kind of a key philosophical difference here. They're both fine for what they are. Skip through too quickly there. Nice thing about this type of model, you get a lot of customer interaction. You get a lot of user feedback, right? So you can see exactly how they are using it in the field. You can also start training early, right? You can start getting your users used to this system. And then you have ideally a whole lot of benefits. The problem is that you oftentimes will put out an incomplete, possibly buggy project, which may sour the experience for the users. If you're doing a game, it's not going to be fully complete, right? All of your quest lines aren't done. However, the user's already seen the core gameplay. Maybe they don't want to come back to it when you're done with early access. Or they find bugs and they get angry at you. So there are positives, there are negatives. Hopefully you can all see now that there are trade-offs for all these models, right? There's not one perfect model as of yet. Agile's pretty good. There are still drawbacks to that. All right, so we have Waterfall, V, prototyping and iterative / incremental. We now have the spiral model, where this one is effectively what it's named as. It's a spiral. So the idea is to kind of combine common steps with each phase of the spiral, I suppose. In each of these phases, you're going to plan, you're going to determine your goals, look at your problems, what the risks are, how you might mitigate those, and then do your development and testing. And so you have 4 key ideas. This is a very, very busy picture here, but the point is that you're going to start at the center of the spiral, you're going to go through your 4 phases, and then you're going to be under the next level of the spiral. And you're just going to keep going and going and going until you get to your release. So each, I guess, spin of the spiral or each circle of the spiral is going to comprise those 4 main aspects. This is kind of a little bit better of a view. It's not as busy. Here you have 5 instead of 4. But you basically are going to do one twist of the spiral. You go through your communicating with your customer, do all your planning activities, all your modeling, your construction, your deployment, and then keep going. Nice thing here is that your entire software development process is limited to effectively what is a prototype or a sprint or a checkpoint or whatever term you're gonna use, right? Everything is kind of compressed. So it's nice in that regard. It's flexible. However, it's still iterative, still relies on communication, good requirements, things of that nature. Right, I'm going to speed up here since we only have 6 minutes left because we all need to talk about Agile because that is the new and exciting thing. Agile is a very, very broad area now because so many people really like it. Key concepts here that I'm going to kind of zip through. The individual and team are kind of the focus here. You would rather focus on software delivery instead of full documentation. Customer feedback and interaction is key here, and being able to handle quick changes is important. So in Agile, we care a little bit less about formal restrictive requirements and more about the people, I guess, is the manifesto that they've released. And what you're going to see if you look into Agile, there are a ton of methods that use this process. There's extreme programming, which sounds like it's straight out of the 90s. I need my neon shirt to talk about that one. We have Crystal Agile, which has a whole bunch of different flavors based on how safety critical it is. You have your Scrums, which is fairly common. You have a Kanban style. Basically, you have a whole bunch of different ways of applying these Agile ideas. All right, so Scrum is where you have teams that self-organize. You have daily stand-ups where you talk about what you're working on for next time. And then the idea is that you kind of have this organic way of developing software. And it can get very, very complicated. With something like Scrum, you're going to need somebody to quarterback or be in charge of the whole process to make sure everybody stays on track. So with extreme programming, this is going to be very common between all of your Agile methods. Communication is important. So not only between team members, but customers, clients, basically everybody with a stake. Focuses on simplicity. So if you're developing a module, it should be as simple as possible. So the kind of keep it simple, stupid paradigm that you should all come to know and love. Courage, this is where we start getting into buzzwords in software. Be happy and be proud and try to develop something really, really cool as early as possible and as often as possible. Don't feel bad about developing something that is not fully complete, basically. So be willing to take risks, I guess, is the idea. And then you have feedback in the loop as well. Let's see what, we're pretty much done. That's good. So the key is not necessarily that we want to do a deep dive into any of the Agile processes, because they all, by and large, are going to be very similar in that they focus on you, the team, you, the individual. The thing to keep in mind is that it's a less requirements focused, right? So if the customer changes their mind, maybe a new law comes up you have to handle, or something changes, there's a very, very, very quick turnaround between change to software release. What's the detriment to this idea? So let me leave you with that one, maybe. Waterfall is very brittle, can't handle change. Agile, on the other side, is great in the change. I get a call from my customer, we need this change. My team can probably turn it around in 12, 24, 48 hours, however hard the change is. I've got some buzzwords here on the slides that I'll let you all read over. This is somebody who is actually quite introverted. I'm not a huge fan of pair programming, but I know a lot of people love it. What's the problem with Agile? So we have simplicity, we have people focus, customer focus, get the code out as quickly as possible. What's the danger with that? Those of you still paying attention. Just kidding. I know you're all paying attention. Bugs, problems, right? Bugs. Yeah, sure. So you find a bug, that's going to be another thing that you have to deal with. Add another sticky note to your Kanban board. We have to take care of this bug today. You also have the problems of rushed release, less safety. Yeah, so there are these aspects here. And what you actually see with Agile, I don't have a slide of this, but once you get done with your programming process, you actually have to start considering these hard requirements if it's something safety critical, right? So requirements you can point to, or tests or verification activities you can point to. Expensive for the client. So yeah, there's a lot of interaction with the clients. You're going to need to basically be constantly interacting with teams. Things might take longer. Yeah, so there's a lot of things here. But what everybody likes about Agile is that quick turnaround. Harder for other people to work on the project. Bring in someone new, it'll be confusing for them. Yeah, onboarding and bringing on other team members is always a challenge too. One of the things that you see with some of these Agile, though, is that people will tend to kind of cross-pollinate, where I'm going to work on this feature today, and then somebody else might work on it tomorrow. So you get a lot of shared knowledge that way, which is kind of nice. All right. Anybody have any other questions? So I've got a little bit extra in the slide here. But basically the idea is it's very flexible. And you can go and get certified as a Scrum Master, for instance. Anybody have any questions on the homework or some of the various processes that we have? I will also send out an announcement for the team meeting stuff because I'm realizing that might be a little bit, well, maybe not confusing. I just want to remind you all about that. But hope you all have a good day. I will see you all Wednesday, and yeah, bye everybody. Since you're a customer, how often are we checking in with you? Let me go in reverse order. I will ask you to check in with me. So we're gonna go a more. It'll probably be closer to an older style of model. So I'm gonna ask you for your project proposal. So that's what's due at the end of the month. Next up, we're gonna start developing some of the more system/code level models. So you're gonna do like activity diagrams, sequence diagrams, various UML models. Then you'll get into writing test cases. We're gonna kind of do a mishmash basically here. So you're not gonna follow a strictly formal process, but I'll give you guidelines for each step. I guess the biggest thing is you're probably going to be doing 2 releases. So you'll do a demo at midterm time. Doesn't have to be feature rich. And then you'll have your final demo at the end of the year. And then maintenance will be up to you if you want to keep supporting it or not. But I guess to Abby's point, it depends how your weekly meetings go. So I'm asking you, what do you have to do this week? Who's going to be responsible for what? That's Agile-ish, right? So it's kind of a mix. So yeah, that's pretty much all I have for all of you. Thanks for sticking around, and have a pleasant day.